pressure I discuss with you. Please join with me. Please don't late. It is a very important part for your exam, for your coming exam. And if you don't clear your all doubts, you can't write anything because there is lots of doubt. Please join with me. Hi. Start. Let's start. Let's start. First, what I tell it, what is atmospheric pressure? What is the definition? Atmospheric pressure is a force. Atmospheric pressure is the force. Who gives it? The air gives it. The air gives the pressure by this pressure is created by the atmosphere and per unit on the surface of the earth. It is called the atmospheric pressure. I tell one more time. Atmospheric pressure is the force exerted by the atmosphere or air on the per unit surface of the earth. Clear? Have any doubt? Okay? Okay. If it is okay, you show a thumb. Then I go to the next one. Next, where the atmospheric pressure acts. Atmospheric pressure acts in all sides. Up, down, side by side, anywhere the atmospheric pressure can work. Number 3. What is the value of the atmospheric pressure? The normal atmospheric pressure at the sea level, it is 1013.25 HPA. Normal atmospheric pressure at sea level. And what is HPA? It is hectopascal. Hectopascal. Hectopascal is the unit. But another unit, there are many units is there. You can write 1 ATM. It is also right. You can write 10000 PA, Pascal. Okay? You can write any one. It is accurate. It is not. It is approximate rate. Clear? We can use hectopascal, A atom, anything we can use. Now, I discuss some experiment where the atmospheric pressure exerted by a huge pressure. How can the atmosphere, how can give this huge pressure? I take a container. This is the container. This is the container. What's happened? It is a one lid, there is one opening. It is 2 liter mobile container. You can put anything. We put water inside this one. And after that, we put this container on a tripod stand and burner on. What's happened? The water starts boiling. At that time, what's happened? No changes inside the container. Means inside and outside there are 2 pressure acts. 2 pressure acts. Inside which pressure? The water starts boiling. Means steam started. Steam making started. At that time this is the outside air pressure and inside steam. Steam pressure. This is outside air pressure. Both pressure are equals. They cut one another, so there are no changes in the container. Then what is the second step? What's the second step? When you saw the vapor comes very fluently from this mouth, then what you are doing? You just close the cap, and after that you pour water. And then at that time, what's happened? The steam inside the can changes into water and down. and there are what's happened, look. The can crushed. Why? Inside vacuum, no pressure. Outside air pressure, too much air pressure. This air pressure change the shape of the container. In this way, we can tell that air can give a huge pressure. Air can give a huge pressure. Clear? Some common phenomena due to the atmospheric pressure. Now, you ask one question, say, here have a huge pressure, then why we can't understand it, why we can't feel it? Because assumption the surface of the body, our human adult body, 2 meters square. So if the square area is more, then the atmospheric pressure is more, and the air, the oxygen is dissolved in the blood. Means oxygen is a gas, so it gives also a pressure inside our body. This pressure is little bit more. It is near about PA. It is more than the air pressure. Means inside this is called the blood pressure. This and you know the all you everybody knows the blood is follow on the suppose mm, what's happened when you go to the high altitudes, means mountain, at that time what's happened, someone have the problem, bloods come from the nose. Why it is happened? It is due to the pressure. In that case, when the altitudes change, the pressure also change. High altitudes of air pressure less, but inside the body pressure there is more body pressure. Due to the more body pressure, the blood comes through our nose. Okay, clear? It is one of the problem of the air pressure, due to the air pressure. Next one. When pain leak in the high altitudes, why it is happening? It is the same reason. In the pain, there is also pressure. When the altitude changes, the air pressure less, and the inside the pressure is more. For due to the more pressure, the what like as the blood, the ink also go up and it leaks. Then one of the positive side of the air pressure. What's the air pressure positive side? We can see the lizard can easily walk on the wall, but we can't do. Why it is happen? On the claws, on the leg, there is a pad. In the leg of the lizard, there is a small pad. It's like as a, it acts like as a sucker. Means when it moves through the surface, plain surface, there is a when the lizard is moved on the small surface. At that time, I vacuum create on the leg, and this vacuum and outside the air pressure is more. Suppose this is the leg, this is a vacuum clean. Outside the air pressure give more, and for that reason it can move on the wall. We can't do because we have no air pad on the leg, and when we walk, no vacuum created, but there is a vacuum created on the lizard legs. For that reason they can crawl, they can walk. On the wall we can't do. And what's happened, the astronaut go to the air means at the space anytime, they use a special type of jacket. This is the same reason, because outside there is air pressure less, in our body the pressure is more, and in that time they are feeling uneasy. So when you wear special type of jacket, the pressure is balanced and they are not feeling any uneasy. Next, what is the unit of this atmospheric pressure? Pascals. Pascal. Okay. Then bar. Bar is 1000 Pascal. One is millimeter. Millimeter of mercury. Millimeter of mercury, it is 760 mmHg. mmHg, but we can tell 1 atm. This is the unit of the air pressure. Unit of the air pressure. Clear? Have any questions? Please continue the class. At the end of the class, I give a tricks for this chapter. Next, we can discuss what is the importance of atmospheric pressure. Where we can use this atmospheric pressure. Weather prediction. High atmospheric pressure, clear weather. Low atmospheric pressure, so cloudy weather. And breathing. In the upside, in the air, in the mountain, the air is less atmospheric pressure and less of oxygen, so we have breathing problem. And the boiling of water is fostered in the low atmospheric pressure. Next is aviation. When the plane is flying, at that time it is need to adjust the atmospheric pressure to fly properly. So it is happen. Next one, what is the barometer? Barometer is an instrument. By this instrument we can measure the pressure of the atmosphere. Now I can draw a barometer. But this is a simple barometer. Pure mercury. Pure mercury. What's happened? It is a tube. One side is closed and another side is, it is a glass tube and it is narrow uniform barrel. And what's happened? I put it is 1 meter height. We put it full mercury and like as this one. Full it mercury and opening we close by a thumb. And then what's happened? I just turned, inverted it on where it is a can by a pot which is it is full of pure mercury and just inverted it. At that time what's happened? First we saw the mercury level down. We look, there is a hollow places. This is the hollow places. And after sometimes one places the mercury stands still. Now I check and measured it. It is this hollow place is called torricellium vacuum. Torricellium vacuum. Then questions why it is torricellium? Because torricellium inverted it. For that reason we call this one. And why it is happened? Why 76? We measure it and it is 76 centimeter. Why it is happened? Because at that time the air pressure gives the pressure here. Outside air gives the pressure on the surface of the pot. And this pressure goes inside this tube. And due to this pressure, this pressure is able to make a column of 76 centimeter mercury column is possible. Not more than. Where it is a normal standard size, 76. Okay. And if when this is column is up and down, then we can understand the weather change. The weather change. When the pressure is more, it goes up. When pressure is less, means when it is a cloudy, then it is fall down. 76 knot, it is 72. And due to this one, we can understand what is the weather and everything. Questions? Jim, why we use mercury? Why you not use the water? We can use water, alcohol, anything we can use, but there are some lots of problems. Why you not use the water? Because mercury is more dense, 13.6 times dense than the water. Water is less density. And normal atmospheric pressure, this pressure gives a support to the water 34 feet height. 34 feet high, but 10.35 meters height it is possible. But what's happened? It is not possible. How can you make this long tube? Is it possible? It is maintenance possible? No, it is not maintenance possible. And say for that, and next the water evaporate very easily, and water expand and contract due to the temperature is more than the mercury. For what's happened, it's up and down, water's up and down more, so the reading is not perfect. So for that reason, and water is too much sticky, it stick on the glass. For that reason, we can't use water, we use mercury. Then what is the suitable point? What is the plus point for using mercury? Mercury dense is 13.6 centimeter cube. Does not vapor easily. Does not vapor under vacuum condition. It is not sticky and expand and contract very less. For that reason, we get a accurate result. And mercury can get pure state. Mercury can get very pure state. So it is very easy to use the mercury. How many types of barometer we can use? We use two type barometer. One is 14 barometers and one is aneroid barometer. Okay? Have any questions? Tell me. Barometer is a normal barometer. It is little bit modified barometer, and here we use the mercury. Okay, and aneroid barometer, it is little bit better. It is portable barometer, and it is a compact barometer, and we don't use any liquid in this barometer. Okay, then come to the point. Lifting of the water by the hand pump. First I draw the lifting. What's happened? It is a hand pump. What is the principle of the hand pump? Number one principle, the air exerts the pressures. We use the pressure of the air, this one. And for due to pressure, water can go up 10.9 10.34 meter. One is air pressure, and second one, due to the pressure, water can makes a pillar, makes a column of 10.345 meters. It can move up to this height, and these two principles on this, the water hand pump is work onto these principles. And now I tell the structure. What is the structure of the hand pump? There are two iron tubes. It is A iron tube. It is little bit larger diameter, and it is the B. It is the B iron tube. It is small diameter, and this A and B. A and B is attached. A B is attached with the groundwater level. And there is a handle. With the handle there is a piston. Piston is one, and there is two valve. Ek is piston valve, this is V2, and one is downward foot valve V1. That is two valve. And the first happen is this piston. What's happened? Let's start from here. The piston is in this point, means zero level. So I first this one, I make it little bit this one. Piston is here. Due to valve is coming near. Then what's happened? You start to remove the piston upside. When it go upside, what's happened? It goes up. It goes up. There is a vacuum crate. The piston remove all the air from here, and at that time the air pressure on the ground it's go down. Due to it is more than the inside pressure, due to this valve open, V1 valve open, water comes inside. It is full, the A1 tube is full by the water. But after water, what's happened? When it is filled up, what's happened? Then it is moved. I draw another one. You move the piston here. Upside the piston go. Upside the piston go. In that cases, the air, the water is filled. Due to the water pressure, V1 valve already closed, and due to the upside air pressure, V2 valve already closed. It is the second point. Upside it is happened. Then what's happened? Then you use the piston down. When you use the handle down, this piston also go down. Little bit first down. Little bit down. At that time, what's happened? The water trapped. This valve is open due to the high pressure of the water. This valve is open and water always trapped. This water can go up. It's not. And can't down also. At that time, what's happened? Next, what's happened? The piston again up. Here the water, it go to the spout, because now the piston go up. It means the water come down. It is already trapped. If due to the two valves open and close, we can do this one. We can get water from the ground. Okay. Now one thing I tell for you, it is most important. Which thing is atmospheric pressure is depend for which thing. I tell this one. This is the most important thing. This is altitudes. altitudes. High altitudes pressure decrease. And for that reason, when we move on the mountain, the pressure decrease. Next, temperature. Hot air rises, create a low pressure. On the other hand, dry air or cold air sink. It gives high pressure. Next, moisture or humidity. Humid. By humidity. Humid air is lighter than the normal air. So humid air gives low pressure. So you please focus these three points: altitude, temperature and moisture by humidity. It controls the atmospheric pressure. It is more important. Okay? If you like my classes, you like my videos, please subscribe my channel. Thank you.